Now that our voxel tree has a trunk, we can add its branches. To generate branches, we'll use the same code for the tree trunk and turn it into a function. This way, the branches of the tree will actually be scaled down versions of the tree trunk. Create the tree function around the for loop. It should accept 3 parameters, the last one being optional. Replace the 0 in the for loop with the current height parameter. Replace the 19 in the for loop with the max height parameter. The parent box variable is the optional function parameter. If it's not supplied when the tree function is called, it'll default to undefined. Press Ctrl E to evaluate the script and to register the tree function into Max. We can now call the tree function from either the MaxScript editor or the MaxScript listener. Calling tree010 or tree010 parent box undefined is syntactically equivalent. The result, however, will be different every time because each tree uses random numbers to determine the rotation values of each new box. It'll be convenient for later to have our tree function return the first box it creates. To do that, we'll declare the first box variable and we'll assign new box to it if it's undefined. In MaxScript, a function returns the last expression evaluated, so we'll just add the first box expression at the end of the function. You could also use the return keyword if you need to exit a function preemptively, but this keyword behaves slowly in MaxScript. Add a fourth optional parameter to the tree function and call it branching chance. Let's give it a default value of 0.15. This parameter will determine the probability of creating a new branch at any given loop. To determine whether or not the loop will generate a branch, we'll sample a random decimal number between 0 and 1. If that number is below the branching chance value, then the loop will create a new branch. The next step may seem strange for those who are unfamiliar with programming. To visualize what we're about to do, you can imagine that a branch resembles a smaller tree which has been glued onto a bigger tree. For this reason, we'll call the tree function from within the tree function to generate a new branch. In programming terms, we refer to this technique as recursion. In the recursive call to tree, the new box is assigned to the parent box parameter. Recall that the tree function returns the first box it creates. Here, the returned box is the first box of the resulting branch. If we run the script now, the branches roughly follow the same direction as the tree trunk. To spread the branches out, rotate the branch box. You can now create a variety of trees by calling the tree function. Change the max height and the branching chance parameters to get bigger, more complex trees. Note that if your chance to branch is too large and if your maximum height is too high, it may take an exponentially long time to generate your tree. The last step is to animate the growth of the tree. Let's take a step back to understand how to animate the scale property of a single box. In a new scripting tab, create a new box. Use the withAnimateOn context expression to open an animation context. Type the following line to create a key on the box's scale at frame 0. Type the next line to create a key on the box's scale at frame 48. When you run this script, the resulting box grows between frame 0 and frame 48. The with animate on context expression acts like the auto key button. Animatable properties changed within the animate on context are automatically keyed at the scene's current time. To change the scene's current time, we use the @time context expression. Now that we've got an idea of how to animate a box's scale, let's animate a tree of boxes. Select the previous tab to keep working on our original script. Create a new function called animateTree and give it the following parameters. The treeBox parameter is any box that is part of a tree. The optional currentFrame parameter has a default value of 0 and will be used to keep track of which frame we need to key next. Similarly, the optional FrameIncrement parameter has a default value of 3. This will be used to increase the value of the next frame to key. Our animateTree function is empty, but that doesn't stop us from calling it to test out our code so far. Assign the myTree variable to the box returned by the following call to the tree function. Call animateTree myTree. No animations are applied because we still have to fill out the animateTree function. Create a for loop which calls animateTree on the tree box's children. Notice that we're using recursion again since we want to key each box's scale at a 3-frame increment from its parent. Once the correct frame value is propagated to each box, we'll store the current box's scale. Now, we can shrink the box at time 0 and key its original scale at time current frame. Evaluate the script and scrub through the timeline. Observe how each box scales to make the tree appear as if it were growing. You should now have a good idea of how to manipulate simple objects, how to create your own functions, and how to perform basic animations with MaxScript.